Yeah, quick read through still, since I stumbled across this one. Let's see, the battery is already very empty. Plasma reactors could create oxygen on Mars. Approach splits atmospheric carbon dioxide, but still has kinks to work out. Last year, NASA achieved something science fiction writers have been dreaming about for decades. It created oxygen on Mars, a microwave-sized device attached to the agency's Perseverance rover converted carbon dioxide into 10 minutes of breathable oxygen. Now physicists say they've come up with a way to use electron beams in a plasma reactor to create far more oxygen, potentially in a smaller package. The technique might someday not just help astronauts breathe on the red planet, but could also serve as a way to create fuel and fertilizer, says Michael Hecht, an experimental scientist at the Massachusetts Institute of Technology. But Hecht, who leads the oxygen-making rover instrument, says the new approach still has a number of challenges to overcome before it can hitch a ride to our solar neighbor. When Perseverance landed on Jezero crater in 2020, it carried the Mars Oxygen In Situ Resource Utilization Experiment (MOXIE). The device was in Martian air, draws in Martian air, which is 95% carbon dioxide, by pumping a current between two oppositely charged electrodes in an electrochemical cell. MOXIE can split the carbon dioxide into carbon monoxide and oxygen ions. The oxygen ions then combine with each other to produce oxygen gas. The experiment has been successful proof of concept, but to work MOXIE needs to pressurize and heat Martian air, requiring extra parts to consume energy and make it bulky. Vasca Guerra, a physicist at the University of Lisbon, thought a plasma reactor might be a better approach. A beam of electrons accelerated to a specific energy level can split carbon dioxide into its component ions or plasma, just like MOXIE. Moreover, a plasma reactor would well suited to be what? Would be well suited to the Martian atmosphere. This was now very difficult to say. Which is about 100 times thinner than Earth's. Creating and accelerating a beam of electrons in thin air is much easier, Guerra says. There is an ideal pressure for plasma operation, he says. Mars has precisely this correct pressure. In the lab, he and his colleagues pumped air designated to match the pressure and composition of Mars into metal tubes. Unlike MOXIE, they didn't need to compress or heat the air. Yet by firing an electron beam into the reaction chamber, they were able to convert about 30% of the air into oxygen. They estimate that the device could create about 14 grams of oxygen per hour, enough to support 28 minutes of breathing. The team reports today in the Journal of Applied Physics. Guerra's team still needs to solve some practical problems, Hecht notes. To work on Mars, the plasma device would need a portable power source and the place to store the oxygen it makes, all of which could make it just as, if not more, bulky than MOXIE, he says. If space agencies were willing to spend millions of dollars developing it, as NASA did with MOXIE, the plasma approach could mature, Hecht says. He especially likes how the electron beam could be turned to split other atmospheric molecules such as nitrogen to create fertilizer. There is nothing wrong with the plasma technique other than it's a lot less mature, he says. So Earth is a capacitor in space. We have clouds in the sky. Like here in this picture, I just searched for one I took today. Maybe I'll make a video about this picture tomorrow. Clouds are plasma. Earth is a capacitor in space. So we are surrounded by plasma. All the clouds are plasma. All the Aurora Borealis and all these, they're all plasmas. How do you think oxygen is created on Earth? Cosmic currents, Birkeland currents going through Earth keeping our magnetosphere and all the other things in place. Through its charge, we have North and South Pole, magnetic North and South Pole, because of the Parkland current, which goes through Earth. And now NASA makes this kind of device, which is basically Earth in a tiny scale. But anyway, I leave it here. Thanks, bye.